Welcome back to the GCSE Maths Pro YouTube channel. Today's video is on finding the area of a sector of a circle. So as always, we're going to have here the formula of the area of a sector. If you've seen how to find out the arc length of a sector, then you'll know that this is kind of very similar. Basically here we have a sector of a circle, and the way that we find the area of this is we're going to first work out the area of the whole circle, which you should know by now is pi r squared. That's just for the whole thing, isn't it? And then to find out just this smaller part of the whole circle, we're going to times that by a fraction. And the fraction is, well, how much of the whole circle do I actually want? Well, in this case, you can see we've got theta, that's representing the angle, out of 360. Now, obviously, around a point is 360 degrees. So if we know the angle of the sector, which obviously they'll give us as a number, then that is literally the fraction of the circle we want, isn't it? Like a portion of the circle that we want. So it's exactly the same as when we did the arc length, except obviously then you would work out the whole circumference of the circle and times it by this same fraction. In this case, we're going to do the area of the circle and times it by the fraction that we actually want. Now this won't be on your formula sheet, so make a note of this formula, but hopefully the logic is there that you can kind of think, well, yeah, makes sense. I'll just find the whole area of a circle, which I know anyway, and then times it by the fraction that I want based on the angles. So I've got the formula up here in the corner anyway for each question. So the first one, work out the area of the sector. Okay, so we've been given 2.1, which is obviously here the radius, isn't it? So to start with, I want to find the area of the whole circle, which is pi r squared, so pi times 2.1 squared. Then I'm going to times that by the fraction of the circle that I want. So actually I've been given 64 degrees. So it's 64 degrees out of the whole 360 that would have been in the whole circle. Once we've written that down, we just need to put it in the calculator. So we've got pi times 2.1 squared times 64 over 360 as a fraction. And here we are. So I'm actually going to give it to, I think, 3 significant figures. So 2.46. Let's go with that. Now, normally if there's decimals, they'll tell you how to round it. But in my case, I'm just going to choose 3 significant figures. Okay, so 2.46 centimeters squared is the area. It's literally as simple as that. As long as you've got the radius and the angle, you just throw it into that equation. Okay, same thing again here. We just have a slightly bigger sector, as you can see. So the area of the sector is pi times the radius squared, which you can see in this case the radius is 17.9, times by the fraction that we want. So we've got 123 degrees of the circle out of 360. And that just goes straight into my calculator as well. So 17.9 squared times 123 over 360. So this time I've got 343.9. Let's leave it to one decimal place. 343.9 centimeters squared. Okay, it really is as simple as that. That's kind of the basis of finding the area of a sector. Okay, we've got another larger sector here, but do you see the difference we've got is that the angle is actually on the outside of the sector. If I come back to this previous one, do you see how the angle was on the inside? So they can actually add this in as a bit of a trick question. In this case, obviously the theta that's in my formula is not the angle on the outside. It has to be the angle on the inside of my circle. So first of all, in this case, I actually need to work out what is this angle on the inside of my circle sector. Now, obviously, we know that a whole circle or angles around a point is 360 as a total. So we've got 360 minus 140. That should give me what's actually on the inside of my sector, which should be 220 degrees. So actually, I can label this now as 220 degrees. And actually, that's the angle I'm going to use in my formula, not the 140. So just double check, have they given me the correct angle? But now I can carry on as before. So the area is pi r squared, so pi times the radius squared, which is 32 in this case, times by 220 over 360. And that will go in my calculator. So 32 squared times 220 over 360. Now it's given it to me in terms of pi, so I'm just going to use this little SD button, which is above the delete button, so I can convert it as a decimal. I think this one I'm going to round to the nearest whole number. So we've got 1966. And that was to the nearest whole number. Okay, so that one just had a little additional step at the start, so just double check if that is the case or not in your questions. Okay, so now that we've practiced working out the area of a sector and using the formula, we've actually got a slightly more complicated question here. As you can see, we've got a sector, and then within that sector we've got a semicircle, and it says work out the shaded area, so just this blue bit here. So you should have seen by now the videos on working out the area of a circle and semicircles to be able to work out this area. But in this case, when you've got this kind of odd shaded area, which is, you can't really describe what shape that is. It's actually a cutout scenario. You might have also seen the video on area of compound shapes, which we have a question at the end, which is a little bit similar in terms of the fact that it's a photo frame and we just want to work out the area around the outside of the frame. So in this case, what I'm actually going to do is we're going to have to work out the area of the whole sector, the area of this semicircle, and then just take them away because the semicircle is a cutout, isn't it? So let's do area of the sector because that's what we've been doing. So we've got pi r squared. Now the radius of the sector, do you see, is actually 1 plus 5, isn't it? It's going all the way across. So in this case, we've got the radius as 6, so just be careful you get that right. Times by the angle, which they've given us is 72, so that's fine, 72 out of 360. And straight into the calculators we did before, so times 6 squared times 72 over 360. You can write this down in terms of pi if you like, but I'm just going to have a little look. I'm going to write down a couple of decimals, so 22.619, let's write that down. Now I'm not rounding it too soon because obviously I haven't actually found the final answer yet. So that's my whole sector, but that's including the semicircle, isn't it? So I'll put it, that's a sector. Now we need to find the area of the semicircle, which if you've seen that other video, you'll know what to do, but you can also use this exact same formula here. The only thing is that obviously the angle, that's the middle, is 180, isn't it? So you can use 180 over 360 if you like. Or if you remember what we did in the other videos, you obviously do pi r squared as normal. Now the radius of this one though, because just remember, the 5 is actually the diameter, isn't it? So the radius is actually 2.5. So just be really careful with that as well. That would be the whole of that circle if you were to continue it around. But being a semicircle, it is only half, isn't it? So either you do that and divide it by 2, which we did in our previous video, or you can times it by the same formula here, but just know it's obviously 180 out of 360. Now 180 out of 360 is half, isn't it? So it's exactly the same thing. Whichever you prefer to do, whichever makes sense to you, it's the exact same answer. So here we've got pi times 2.5 squared times, let's say 180 over 360. We get 25 over 8 pi, or as a decimal, 9.817. Now I'll just go back and show you if I were to do it the other way. I would have pi times 2.5 squared over 2. That's the other way, isn't it? Do you see how I get the same exact answer, 25 over 8 pi, or 9.817? I'm just going to write down as well a couple of decimals. 817 dot dot dot. Okay, so I've got 2 areas here. Now in this case, because it's a cutout, isn't it, I'm going to subtract them. I'm not going to add them like we do with other compound shapes. So the last bit is the area of the shaded region is, we've got 22.619, which was the whole sector, minus 9.817, which was the semicircle that we need to cut out, which gives me 12.802, which I'll just round to 12.8. And that's 1 decimal place, isn't it? Okay, so that's your final answer there. So that's how they could make this topic a little bit more complicated, okay? They might throw in a shaded region that is a bit of an odd shape, and you have to work out multiple things to then subtract them at the end. Either way, we still ended up using the same formula. Okay, so that is everything you pretty much need to know on area so far. The final video on this topic is area with algebra, so it will be covering quite a lot of the shapes that we've already looked at, but in the context of using algebra, as a lot of the time in exams they like to combine 2 or 3 topics together in a question. You do often get a lot of area and algebra together. Otherwise, that is everything we need to know on area. After this, the next topic to look at would be surface area. So thanks for watching this video. If you found it helpful, make sure to like and subscribe and leave down below any questions or comments that you might have.